Hello everyone and welcome to another AP Computer Science video. We're going to continue today with iteration, specifically the while loop format. There are different ways, and so we'll finish up with this video using while loops in different scenarios, and then we'll move on to the next type in another video. So just as a quick refresher, we saw a while loop is essentially an if statement that can be repeated. And what happens is we ask a question. If it's true, we run some code, very much like an if statement. But what changes, instead of moving on after the loop, we go back to the question and ask it again. So this is why we use the word while. We say while some condition is met, continue to repeat some code, and eventually, if it's done correctly, the condition will no longer be true. It will not be met. It will be false, and then the loop will stop. So that's the goal that we did. We did small examples. We did going from the numbers from 1 to 10, doing the numbers from 1 to 10 evenly, doing the numbers 1 to 1,000 or 1 to 100 evenly, even numbers only, starting at the bottom, and then going backwards, going from 100 down and doing the multiples of 6. So the general idea is always the same. Essentially, we have some variable that's a counter, or you might also hear the word sentinel variable. It just kind of it keeps us aware of what's happening. The condition is usually based on this variable in some fashion. In our examples, this num variable, which was an integer, is what kind of controlled the iteration of our loop. And so once you have that variable, then the condition must be true. And so the condition also affects how many times this loop will occur. And then within the body of the loop, at some point, something must change that sentinel or counter variable so that the condition is eventually false. And in this case, num would be increased by some amount, either by 1 or by 2 or whatever it happened to be, and eventually the statement of number being smaller than 100 or greater than 0 would eventually stop, is the idea. So what we're going to do is we're going to make a new Java class just to keep it separate. And it is going to be while loops, but we're going to focus on maybe using strings, because now that we have the ability to repeat ourselves, things that are simple to do with, or seemingly difficult to do with strings, if you don't know the size of the string ahead of time, become much easier. We can be flexible and say, you know what, I don't need to know the length of a string to effectively go through it, or I don't need to know what kinds of characters are inside of it to effectively repeat myself in some fashion. So we'll do some examples. So I'm going to say whiles with strings, or while with strings, not with the S. So while with strings is my class name. And so our goal here is to use while loops, but in a way that lets us manipulate strings. So maybe we'll use substring or index of or things like that. And so let's go ahead and try making our main. And so a good example to start with, I think, though it might seem complicated, this is actually a pretty common thing to do, and we've sort of used scanners in this fashion, or we could potentially use scanners in this fashion to read an entire sentence but break it up into pieces. And so we know that the next command of the scanner class allows us to take a string or something from a console and read it by white space. But we could theoretically take an entire line and then do the work ourselves. And so this is what I'm going to do, is I'm going to have a string that may have multiple words separated by, we'll start with spaces, but the symbol itself is pretty arbitrary. And then cut it up and print each number. Actually, let's do something a little better than that. Let's make a string that is a collection of numbers separated by commas, which is a pretty common thing in what's called a CSV file, or comma separated file, or comma separated values file. And then take the numbers that are separated by commas and sum them up into one final value. And so this is going to teach us two things. One, to use a loop with a string to maybe break it up, and then a particular method that we haven't really seen before because a scanner did it for us, but it's convenient to have done for us. And so we're going to try this out. So let's go ahead and make a string. And I'm going to call it content. And again, for my example, I'm going to say it's a selection of numbers, whole numbers, integer values separated by commas. So let's say like 12, and we won't do spaces. We'll just keep commas only. So 12, 30, 150, negative 20, 10, and 13. So the numbers don't matter. It's just an example. So what I'm saying is we're going to attempt to take the string, break it into its subsequent or individual pieces 12, 30, 150, negative 20, and so on, interpret those numbers, which are technically strings, as integer values, and then sum them together. And a while loop is a great way to do this, because now, I mean, I could probably do it without a while loop because I know what's inside the string. I wrote it myself. But in a real situation, this string might come from a file, it might come from the console, from a human being, it might come from a database, it might come from the internet. And so we wouldn't necessarily know what values are in it, nor how many. And so we're going to maybe attempt to do this dynamically with a loop, with a while loop, and not worry about how many things are inside of it. We just say, you know what, as long as there's something to read or cut up, let's attempt to do that and sum the values. So we're going to need some variables to start with besides the actual content. I'm going to say the first thing we're going to need is maybe a variable to keep track of the sum. Right? So 12 plus 30 plus 150, all those things are going to get added together, and we should put them into one value. So let's make an integer variable, since we're going to assume whole numbers, and we'll call it sum. And initialize it to the value 0, because initially if we read a string that has nothing in it, the sum is 0. We could maybe use a variable. And so now what is going to be our sentinel variable or our counter variable? I'd say in this case we're not going up by character per character, but maybe instead by commas. And so we need to know where those commas are. And so if you don't remember, do we have a method of the string class that we can look for something and it gives us back the index of that something? So for example, I said, can you find me a comma? And we might get a number back that represents the index of the comma that we've just seen. So and the answer is actually we can do that, and that method of the string class is the index of method. So let's go ahead and make a variable, and we'll call it comma idx for comma index, and we'll initialize it to -1. Well, actually, no, sorry, let's not do -1, but let's initialize it to the first call of index of and say, can you find a comma? And so let's say content.index of a comma. So can you find a comma in the string, and if so, what index does it appear at? And so knowing our string, we know it's going to appear at 0, 1, 2, position 2 or index 2. And so what should our condition be to continue to do the work? The work is going to be to take the number up to the comma and add it to the sum and then try again. And so basically our condition should be as long as we can see a comma somewhere, then we should continue doing this separating. And so our condition, we can write that as while. So I'm going to maybe put a space so we can put maybe English words to it. But we'll say while the comma index is greater than -1. Right? Because if we remember the implementation of index of, it says return an index of the searched for string if it is found in the calling string, and if it is not found, return -1. So if somehow we did not find a comma, then -1 would be returned and stored in comma idx. -1 is not greater than -1, the loop would be false and we would end. So potentially this could run 0 times, and we'll test it on strings that have different inputs and we'll know whether it works or not. But if you are above -1, that means 0 or larger, then theoretically a comma has been found, and we want to read everything up to the front, from the front of the string to that comma. Now this is also going to have some side effects. We're actually going to be manipulating content and slowly kind of chopping it up, and we have to be okay with that. Or we must come up with a way to copy it if we don't want to touch the original. In this case, I'm okay with kind of destroying content or manipulating it in some way. But we have to be aware that that is a side effect of what we're going to be doing. And if we don't want to do that, we have to be very careful. So let's take a substring from the beginning to that comma that we just found. So we're going to say string piece, and we'll say it's equal to content.substring 0 to wherever we found the comma, which is comma idx. And remember, it's not inclusive, so the comma will not be part of the number, which is exactly what we want. So in this idea, we would take from 0 to 2, but not including 2, so 0 and 1, which would be 12. And this would be a string, so theoretically this would be the value 12. So let's put some English to this word. So we'll say, while we have found a comma, take the content up to, but not including the comma, right? So in this, theoretically, the first time around, we should get the number 12. Now again, this is a string, so we can't just add it to sum, because a string cannot be added to an int to get an int. So here's the other piece of information that we haven't really seen before. With a scanner, we could have used the next int command and it would have broken it for us. So instead, an older style of doing things, which is still valid, but can potentially cause a crash in our program. And thankfully here we know that it won't happen, but we could potentially need to code to handle that gracefully if we didn't know where the input was coming from. Is a command, and we'll say integer.parseInt. So integer.parseInt attempts to convert a string object into an int value. So it tries to make a string into an int, basically. And so we got a string, potentially the 1, 2, and let's convert it to an integer. So we'll say int num is equal to integer.parseInt, and we're gonna parse piece. And now if you notice the format, remember we had talked about static methods that didn't have a context except for the class they happen to be in. And this is one of those static methods. It says, look, integer is actually a class. It's a full word, it's capitalized and everything, and it has a special, it's kind of like the math class, but it has a special method called parseInt that returns the conversion of this string as an int if it can be done. If it can't, it may crash, and this is similar to a scanner. A scanner, if you call next int, will attempt to convert it, but if it fails, it will crash, and if you haven't coded to handle that crash, which we don't really know how to do just yet, it's going to break your program, and we have to kind of accept that. So here we're not going to worry about it so much, but in the future we will talk about solutions for gracefully dealing with errors and mistakes on the part of the input of the data, which is definitely a big aspect of programming in general. So assuming that it's converted, we could add it to our sum. So I can use the compound assignment operator, which is the same as saying sum equals sum plus the value. So add the number to the sum, and that's the new sum. Now, if we stopped here, this would not be great, because the problem would be we are never editing comma idx, so it's always the same number. And theoretically, since we're starting at the beginning of the string, we would get the same number every time. So we would add 12 and add 12 and add 12 and add 12, and it would just kind of be a huge problem, and it would potentially never end. So we have two steps to take. One will stop the loop from going on forever, and the second will guarantee we don't accidentally take the same number over and over again. So they need to both happen for this to be effective. So the first thing we need to do is kind of pretend like the 12 comma is not there. So we're going to adjust content and say, you know what, and since we took the 12, remove it from the string. So how are we going to do that? So we'll say remove the previous number from the string. And we're going to do this by saying content is equal to what it was, but only the substring of that from the comma forward. So from the comma this way would say, you know what, drop the 12. And in fact, it's not the comma included, but without the comma, so we should go one beyond it. So if the comma was at comma idx, then we want to begin our substring at comma idx plus 1. And remember, if we give the substring one integer value as an input, then the assumption is it's going to go to the end of the string. So we're basically saying go from here, 30 to the end. And then when the loop repeats, theoretically we would get the 30, add it to our sum, and then try it again, but we would do from 150 to 13. And then again and again, eventually we would get to the end and there would be no more commas. So we adjust content. Oh, actually this should have been ahead, so let me quickly fix this. So there's our sum. We adjust our content, and now that we've adjusted a string, we should search for the comma again, because we're not going to find the same one because it's not there anymore. So now we can say comma idx is equal to content.index of the comma. And again, this is important. If one of these lines is missing, this is not going to work effectively. If I removed line 25, then we would find the same comma every time, and we would constantly get 12. We might eventually, I mean, it would never, the loop would never end. If I remove line 26 but kept line 12, then we would maybe not, we would probably cause a crash, because what we do is we wouldn't change the string, but it wouldn't look for the comma, and it would do the same index every time, and then the string is going to get shorter, and then basically our parsers probably would not work. So both of these lines are very important to the functionality of this loop. And so theoretically, if at some point comma idx is less than 1, then we would see our resulting value, which is the sum of all these numbers. So let's go ahead and print out our sum and see if that works out the way we expect. So sum, and we'll print out the sum variable. So here we go. I'm going to run it, and hopefully I didn't do anything too wrong, and we'll see some output that makes sense. So it's loading. 182. And let's quickly verify it. 12 plus 30 is 42, plus 150 is 192, minus 20 is 172, plus 10 is 182. Oh, I did something wrong. So we actually missed the last one, and that makes kind of sense. I realize that now because the last column we found was this one, so we did not see the 13. And so we almost got it all. The answer was not 182, but should have been 195, but we lost the 13. So what we should do is, what is the solution? And this is kind of a good example. I'm glad it worked out this way, because the reality is the loop did most of the work, but we ended up with a string with one extra number in it. So we should ask a question. Before we print our sum, it's possible that there's one number left over. And so we should ask that question and say, if the string, so if our string is content dot equals, so we're going to ask, is it an empty string? And actually, what I want to do is the opposite of this, because if it's an empty string, there were no more numbers to use, so our sum is correct. But if it wasn't an empty string, so if it was just 13, 1, 3, then we should add it. So let's do the negation of this. So we're going to say not equal to. So in English, we're writing if the content was not equal. In other words, there is still one number. There's still one number left. And so if it's not equal to a thing, then we can convert that number. And so let's go ahead and say int num is equal to the integer dot parse int of content, which is just the single number. And then let's add that to our sum. So sum plus equals content. Oh, not content, I'm sorry, num. There it is. And now let's run it, and we should get hopefully 195 if we did this correctly. And there it is. The 13 is not lost. And so now you might say, well, is this really necessary? Let's go ahead and prove different scenarios. So we did a scenario with many comma-separated numbers. Let's simplify it. Let's do 2. Theoretically, 2 should work out for both, so we should get 42 as an answer. Let's see if that's the case. And there it is. Now let's do the 1. Just 30. The sum of 30 is 30. And there it is. Now I'm going to go ahead and show that if I didn't have this part, if I commented it out briefly, and I ran it, we would get 0 because one number by itself has no commas. The loop runs 0 times because immediately the index of was -1, so the loop does nothing. And then without the if statement to check if there's something in the string, then we end up with still a sum of 0. So it's important that we have this extra step of saying, hey, is there something in it for whatever reason? And let's do one last check, because this is the one that's tricky, and you might argue you don't necessarily need to do an if statement. You might just do this extra step no matter what. But I would argue it's important that we don't, because what happens if we did this? The sum of no number should be 0. And there it is. And if I do this, if I assume that there's going to be at least one number, when I run it, that might be a problem. And there it is. It says, look, I can't convert an empty string to a number. So we cannot assume that there is a number in the string. I mean, we could, but it's dangerous. And so it's a better bet to say, you know what, cover every scenario. The empty string, no numbers, one number, and more than one number, 2 or more, 2 to infinite number of integer values. And so that's the idea here that we're having. So we're going to go ahead and, oops, I should probably close that. So we're going to go ahead and finish that up, and there it is. And so we get our sum correctly, and that gives us the sum of one number or many numbers, or is no number. So this handles kind of all scenarios. So let me go ahead and put back 12, 30, 150, -12, 20, and 13. Oh, I didn't mean to put spaces. Let's do that. So this is a pretty complex scenario, but still the loop is still the same content. It is some sentinel or management or counter variables. In this case, it's the comma IDX, which is the key to the loop. The condition that must be met in order to do some work, and then the work is whatever it is, plus a little bit extra to make sure that the condition is eventually false. Sometimes it's false immediately, sometimes it's false after a bunch of iterations, sometimes it's false after one iteration. The idea is that it should be flexible to handle all scenarios. So let's try something else. Let's take a string, and we'll make it equal to, and we'll do something like this. And why don't we make a loop that takes whatever the string is and prints it out with alternating capital and lowercase letters. So in this case, capital J, I, M, B, O, and so on. What I would like it to do is the first one will be lowercase, the second one will be upper, the next one will be lower, the next one will be upper, and so on. And if there is no upper or lowercase equivalent, then it just continues. So in this example, we should get the result that I want is to look like this: J, I, M, B, O. It would be a capital J, and then a capital space, which is nothing. So then we'll end up with a lowercase j, a capital O. So it'll look like this: a lowercase n, a capital E, and a lowercase s. So that's the result I want: alternating uppercase and lowercase letters. And if a symbol that happens to be in the string does not have an uppercase thing, you just count it as if it was done. So the uppercase of the space is just a space. So let's try doing that. Generate a string that is alternating characters, upper and lower case. So our string is name, and so what are we going to do? We're going to build a new string. So we have an original name, and we can't really manipulate it, or we could, but it would be really difficult. Instead, let's build a brand new one from scratch. We'll make it empty, and maybe we'll look at every single character, and then when we have a character, decide if it should be upper or lower case, and then based on that, add it to our string in the correct version. So this might take up some work. The first thing we might need is our result. This is kind of like the sum, but in this case, the sum is actually a string of characters being built together. So we'll call it alt for alternate. We'll start it off as an empty string, so it has nothing in it. And then now we need a while loop that goes through every character. Every character, if we remember, in a string has an index, so using a number is a very convenient thing to do. So let's go ahead and do that. Let's make an integer variable and call it idx. And let's start off at 0, because the first character of any string is index 0. And so what should be true for us to continue to do our work? And our work is going to be to build up this string as we go through each character in the original. So we're going to take a letter, capitalize it or lowercase it, and so on. And so we're going to say, you know what, as long as the index is a valid index, so 0, 1, 2, and so on, as long as it's within the range of indices for the string that we're looking through, that's what we should continue to do. And so how do we know that an index is valid? If it starts at 0, that's the first character. We can say, well, idx is less than how many characters are in the string, and we have a method that tells us that in a string class, which is the length method. So while the current index is within the range of length, and remember, if the word is hello, that's 5 characters, the length is 5, the indices would be 0, 1, 2, 3, and 4. So when we get to 5, 5 is not less than 5, and it would stop safely. We would not go outside the range of our string, otherwise we would cause an error. So this is a good condition to have. So now what are we going to do? We have to ask a question. Well, should we capitalize or lowercase? And so there's many ways to do this. We could maybe make a Boolean variable, and it could tell us capitalize or not. Or maybe to save ourselves that creation of a variable, we can say, well, if we assume that we start with lowercase letters, that means that 0 is lowercase. That would imply that every even number is lowercase. So 0 would be lowercase, 2 would be lowercase, 4 would be lowercase. And then the odds, 1, 3, 5 would be uppercase. So let's ask that question. Are you even or odd? Is the index even or odd? And if it's an even index, then we start with lower. And if it's an odd index, then we start with upper. So if the current index is even, how do we ask if something is even? We modulus it by 2, and if we get 0 as an answer, that means it was evenly divisible by 2. So if the mod by 2 is equal to 0, then we know that we are in a lowercase letter. And so the letter we're going to put into our alt, we're going to attach to our alt, so plus equals here is not addition but concatenation, is going to be the current character in name attached but as a lowercase letter. So how do we get the current character in name? We should probably do that first. String cur char. How can we get a single character from a string? There are multiple ways to do this, but we're going to stick with the kind of AP Computer Science A answer, which is to use the substring method, and it returns a string. And so what would the range be for our substring? So if I'm in the example Jimbo Jones and I want the J, what indices would I want? What would my range be for a substring? It should be from 0 to 1, not including 1, which is just 0. So that's our range. But 0 and 1 are kind of coded for only the first one. If I was looking for the M, what would it be? It would be 2 to 3, not including 3. So for our index IDX, then we're going from IDX to IDX plus 1, not including IDX plus 1. The result is one character at a time. And this is a very common thing to do if you want one character at a time, is to go from IDX to IDX plus 1, or whatever your variable happens to be called. So we're going to say name.substring from IDX to IDX plus 1. And because it's not inclusive, it's basically only getting the character at IDX. And so the result is that's a single character. And then now let's make it lowercase. So cur char is equal to what it was, but as a lowercase character. And then we can add the cur char. In fact, we can probably be smart about this. Since this is the only part that changes, we should maybe make this variable outside of the if statement, assign it in the if statement, and then add the thing at the very end. We could do it this way. I'll do it the long way first, and then maybe we'll see the short way of doing it. So in other words, the else scenario is, well, it wasn't even, it was odd. So we should do what? The same exact work, but make it uppercase. So I'm gonna be lazy. I'm gonna copy these 3 lines, except the only difference will be to uppercase. And so at the end of this loop, eventually, now there's one thing missing, which is super important, is in both scenarios, IDX must increase at some point. If it does not increase, the loop never changes, the condition never changes, it's going to loop forever. So before we're done, whether we were even or odd, we should make the IDX go to the next index, which we can do with IDX plus plus, or IDX plus equals 1, or the third type, IDX equals IDX plus 1. So there it is. And so now let's print this and see if this actually works. So let's print out our result, which is going to be alt. So let's see what happens. So our input was Jimbo Jones. I said it should look like that. Let's see if we got what we expected. And there it is, Jimbo Jones. And now what I mentioned was, could we save ourselves a little bit of work? And the answer is probably. We duplicate these lines except for one line. If you see yourself doing a lot of duplication, redundancy, the same lines over and over, you can probably, it's very much like kind of factoring. You can factor out the commonalities and bring it out. And so the commonality is the creation of this variable, and then the addition of the character to the alt variable that already exists. The only unique part is the assignment of a lowercase or an uppercase variable. So let's go ahead and pull that out. We'll say string cur char, and we'll make it empty just to be safe to begin with. And then now here all we have to do is say, okay, well, this is going to happen no matter what. In fact, we don't have to actually make it equal to this. We can literally just do this entire line. So that was my mistake. Let's go ahead and put it right there. So we take the character. Oops, what did I do? I moved something over an accident. Substring. There it is. And then now this line is no longer necessary because it happens no matter what. The first thing we do, no matter whether it's even or odd, is we take the character by itself. This part is unique. This part is in both, so let's take that out of both of them. So this is no longer necessary. And it has to happen after we have figured out which one it is. And there it is. So let's go ahead and format this real quick. And so now notice that our if statements are smaller. These 2 lines are not duplicated. So we went from 6 lines plus the if statements to 1, 2, 3, 4 lines with the if statements. And so it's a little bit better. And again, this may seem like a small change, but it could, in the long run, be worth doing. So let's go ahead and run it one more time. Let's see that there's no difference. And there it is. And let's test it on another string. Let's test it on the word hello. All lowercase. If I run it, we should see lowercase h, capital E, lowercase l, capital L, lowercase o. Now let's do an empty string, and we should see an empty string because there are no characters to manipulate. And there it is, it's an empty string. Let's do one letter. it should be lowercase because it's only one. So notice the loop is very flexible and can handle any sized string. And that's the key to this repetition, is we're not assuming anything about the length. We say, you know what, however long you are, we will go through every spot. We will retrieve one character at a time, and we will determine if they're even or odd, and then build our answer from that. So this is a good place to end here, because we can see the flexibility. And there are many, many uses of strings. There are just kind of an endless supply of possibilities, and loops really give us the flexibility to solve almost any problem. And we're going to continue in our next video with a different type of loop. The end goal is the same, repetition, but we'll see that some problems lend themselves to a different format. And it's a matter of comfort with which version you want. And the bottom line will be, it doesn't matter what style you use, they all can do the same thing. That's kind of a key that we're going to see across iteration, no matter what type of loop we choose to use. And we need to know or be comfortable reading both for the AP exam, and because realistically, if you ever read someone else's code, it's likely you'll see both. Many people are comfortable using different ones, and it depends on the context, so we should know both. And we'll see that second one in our next video. Hope to see you in that next video.